Now, the expanding universe is evidence for the Big Bang Theory. And at this point, I'm going to apologise to all the astrophysics fans out there, because what we're going to do today is an extremely simplified version of the Big Bang Theory for your exam. If you really like this stuff, you can go online. There are so many university websites that you can read which really go into the details of this stuff. So I'll try and remember to put a few links in underneath the video. But today, the basics for your exam. So the basics are these. The Big Bang Theory says that the universe, and by that we do mean time and space, began. So time had a beginning, space had a beginning, and that was about 14 billion years ago. And since then, the universe has been expanding and therefore cooling. Okay, and there are two pieces of evidence that you need to be familiar with. The first we've already talked about, the redshift of distant galaxies, which provides evidence for the expansion of the universe. And the other one is the cosmic microwave background radiation, which we usually abbreviate to the CMB. Now this is, as the name suggests, microwave radiation, so microwaves, and it comes from all directions. So if you have a microwave receiver, you can point it any direction in space and you will pick up basically the same wavelength of microwaves. Now there are sort of small fluctuations in it, and you've probably seen the map that kind of shows you the slightly different colours, but basically it's uniform. Whichever direction you point it in, you're going to pick up the same wavelength of microwaves, and it's everywhere, and that's forming like a background to whatever other radiation you might pick up from galaxies and things like that. Okay, so where does this come from? According to the Big Bang Theory, soon after the Big Bang, and I say soon after, I think it's like 300,000 years or something, but you know, in relative terms, soon after the Big Bang, electrons stick to protons for the first time, and this allows light to actually get through the universe without continually hitting things and being absorbed. So it's like suddenly photons can get through the universe, and at that point they are gamma photons, so very high frequency, very short wavelength, and those gamma photons basically haven't hit anything since then, so they're still going. But now, because the universe has expanded so much, these gamma rays have been stretched so much, they've been redshifted so much that they're now microwaves. And this is what you're picking up. So when you pick up one of these microwaves, your receiver is the first thing that has hit since soon after the Big Bang, when it was first created, and it was a gamma ray. Now, the reason this is such strong evidence for the Big Bang is because, as I say, this theory has huge amounts of maths behind it. It's a very complex and well thought out theory, and the maths predicts exactly what wavelength this microwave radiation should be. And in fact, when they finally detected it, they had the right wavelength. So this was a really amazing prediction. And so very convincing evidence that the Big Bang Theory was correct. Okay, and we don't normally say the wavelength though, we say the temperature that it corresponds to, more in the next video, and that temperature is 2.7 Kelvin. So cosmic microwave background, you get it in all directions, it's basically the same, it comes from all directions in space, it's microwaves, and it corresponds to a temperature of 2.7 Kelvin. So we say that the universe has a temperature of 2.7 Kelvin. Okay, the question for this video is that one at the top there. Have a look at that. Okay, and you get a mark for any 5 of the following. The intensity of the CMB is the same in all directions. Although it does have some ripples in the intensity. It was produced when matter and radiation decoupled. That's a reference to the fact that the universe went transparent to radiation. Another mark for saying that it was originally gamma radiation. Another mark for saying it's been redshifted to the microwave range. Another for saying that this is evidence that the universe began with a Big Bang. Another for saying that it corresponds to a temperature for the universe of 2.7 Kelvin or 3 Kelvin, and which was predicted by the Big Bang model. And finally, it says you can have a mark for sort of linking the evidence to the explanation.